Hey 12s, we are going on with our next example, which is now finding the shortest distance between a plane and a point. So just to give ourselves a visual, we've got our axes. Now we're trying to keep it simple in the diagram, so even though it's a 3D situation, we're just showing it in 2D just to get an idea of what we're looking at. So we're looking at a plane from the side, and then we've got our point A. Now we know the shortest distance is always going to be the perpendicular, so we know that this normal to the plane, which is obviously this vector here, is going to be, our point A is going to be somewhere along that, so that's going to be our shortest distance. And the point where that intersects, we're going to call that point C. So let's define AC. So we know AC is actually just going to be the point A plus some multiple of that direction of the normal. Okay, so we've got our point A, and we know that it's in this direction, so we've got some scalar multiple of that. So what we know from there is that there must be some value of lambda that gives us point C. And because we know point C is on the plane, when we dot these two, it has to equal 7, because we know all points that exist on the plane dot to make 7. So now all we have to do is start working through, so let's dot those two. Simplify, and we get lambda equals -1. So to find the shortest distance, all we have to do is put that into our AC equation. That gives us AC is 2, 0, -1. Check, always check if you are doing this on your own, that it actually does work on the plane. So if we put that in, what have we got? We've got 2 times 3 is 6, 0, and +1, 6 plus 1 is 7. So it definitely does work. And the shortest distance, of course, is then going to be the magnitude, which is going to give us the square root of 5. Okay. Our next two examples, we're going to do the same question in two different ways. Now what we're looking at is the distance between a line and a point. So still 3D vectors, but now we've just got a line equation and a point. First method we're going to use is scalar product, and the second method is going to be cross product. So, excuse me. Okay, so we've got this line and point B. So let's do a quick sketch of what we're looking at. So we've got our starting point in our line equation, and then our direction vector of 2, 1, 7. We've got the point B, okay, and let's call D any point on the line. Now I've just drawn this, however, to start, because we know D is any point. However, what we do know is that the shortest distance is when this is perpendicular, okay? But we're just saying we're going to find any point and then make that perpendicular. So let's start by defining BD. So we know BD is OD take OB. OD, because it's a point on this line, is just going to be our line equation, where obviously we don't know what multiple of lambda we have yet. And we know OB is 2, 1, 3, so that simplifies. Again, as we said, we know the shortest distance is when BD is perpendicular to AD, so we know those two are going to dot to give us 0. All we need to know is the direction of AD. We don't need the whole line equation, because obviously that direction is always going that way, and we're just looking to see when is that perpendicular to BD, what point on that line. So direction of AD, so we're going to put that into BD dot AD. We know that has to equal 0. Right, continuing on the next page. So that's what we're going to dot together, and now just start working through. So expanding, simplify. We get lambda equals -11/54. So now we know the shortest distance is just going to be the magnitude of that, which gives us 1.94. Okay. All right, we're going to do the same question again, but now using a different method. Now, I know you might find this next method a little bit more complicated, but as we know, it's nice to have a few different strategies in case we're given a new situation where the scalar product might not work. So, same question, same numbers, so we can check to see if we get the same result. This time, we're looking at using the cross product, okay? So, let's do the diagram again. This time we need to put a bit more information. So, we've still got our point A and our line. We've still got our point B, which we're trying to find the shortest distance. We've still got D, which is a point on the line. But this time we are going to define point C, which is the perpendicular. So we're going to put that on there. And then we're also going to define this angle theta. So what do we know about the cross product? So we know that AD cross BD, the magnitude of that, is the same as AD BD sine theta. So make sure you can identify all those. So AD BD, we know when we cross those, that's also going to be the same as the magnitude of this, and sine theta. And keep in mind as well, guys, it doesn't matter which angle we use because sine of the acute and sine of the obtuse is the same thing, isn't it? All right, what else do we know? We know because this is a right angle triangle, because C is the closest point, which is the perpendicular, we know that sine theta is going to be opposite over hypotenuse. So we can actually define BC as the hypotenuse, BD, sine theta. So now if you have a look, we can actually substitute this straight into our cross product equation and eliminate that angle. So now we have the cross product AD, and instead of writing BD sine theta, we can just write BC. All right. So we're trying to find BC, so let's arrange it in those terms. Now, AD, because this can be absolutely any point on the line, let's just keep things simple, and we'll let lambda equal 1. So AD is just going to be 2, 1, 7. Once we know what AD is and we know the point A, then we can define D. Okay, make sure you agree with how we've got those. And now once we've defined D, then we have BD. Okay. All right, keep going through. So now we've got all the things we need to substitute into our equation here. So we've got BC is AD cross BD over AD. AD cross BD is 9, negative 11, negative 1. So that's just substituted, that's just done in our calculator to save ourselves a bit of time. The magnitude of AD is going to be 54. Simplify, and we get exactly the same answer that we got using the scalar product. Now, there are e-activities for this in Specialist, in the Specialist V folder. I might do a separate video on the e-activities a bit later. Okay. So this is enough to get you onto 5C 1.1. So there's a few more questions in this, but make sure those are the ones that you do. All right, I might stop there, and you guys can see the next lot of examples in the next video.